Hello everyone, and welcome to this lecture. In last week's lectures, you were introduced to economic complexity. First, you were introduced to the concept of unobservable capabilities and how they drive diversification and complex economies. Later, you were introduced to the idea that you can use network science to try inferring these undefined, unobservable characteristics from the network structures. And finally, you went to the math part and you saw how to compute these indices. We will go back later to talk about it. But this is the general structure of the past lectures. What we'll do today is connecting these exercises to policy. First, policy in general, so how to use data for policy, and then sustainability in particular. So, today's class will have three parts. First, we will have a generic introduction to the use of data for policy, why data is important to have informed policies, and which kind of question data can answer, and which kind of question data cannot answer. Second, we look in particular at how economic complexity can be used to inform policy in several different contexts in general. And finally, we will look in particular at the impact on sustainability, so how to deal with sustainable policies and how economic complexity can help in this. Let's start on the general idea on using data for policy. Decision making in general for policymakers or for a businessman more and more requires data. This is true for any complex system. In particular, of course, for policy. The point is that to take any decision, you need a model of the world. What is going to happen tomorrow? What is going to happen if you do something or if you do something else, right? And to build your model of the world, you need data and the ability to use data, the ability to understand data. And the more complex is the system that you are studying, the more data you need and the more you need advanced techniques to study, to use this data, to understand the model of the world. Let me start with a story. A story to illustrate why we need a world model to take policy decisions. This is one of the first stories of policy debate that we have from history. This is 150 years before the conquest of Alexander the Great, the conquest of Chandragupta Maurya in India. This is 250 years before China unification by the Qin dynasty. It's a story told by Plutarch, but also by Herodotus. And it's a story that regards Athens and around 500 years before Christ, they found a new silver vein in Laurion. Now, Laurion was always full of silver and historically was a place where Athens was mining silver. But they found a new vein that they had that was underground. So a new vein that was rich, and a new vein that would change completely the wealth of the area. Now, it's a lot of money that changed the structure of Greek economy, and Athens had to decide how to use it. And there are two positions, right? And one position is, okay, let's distribute among the citizen, rich citizens, not everyone. Athens was the first democracy, but it was a democracy where you had to have certain wealth to be a citizen. So it's not really spread around, but distributed to the rich families of Athens. Or we collect the money as a country and we use them to build a navy. Why to build a navy? Because Persia is going to attack. And now there is a debate, and we know the debate. We know what they said, the parts, because we have the discussion by Plutarch that wrote what the people were saying, and the discussion is really about the world model, right? Because it's very clear what is better if we know what is going to happen. If Persia is going to invade, we don't. Even if we have the silver in, everyone is richer. Doesn't matter. Next year, everyone will take. So Persia will come and will take our silver. So if Persia is going to invade the next year, it's clearly better to have built a navy. But we don't. But what if Persia doesn't invade next year? Then we spend all this money to build the navy. We'll have a cost to maintain the navy next years, and it's useless because Athens for sure cannot go to invade Persia with that navy, right? It doesn't have the people. Athens is a city. Persia was an empire, right? So this is it's a clearly a question of what is going to happen. How can we forecast the future, and how this will affect our policies, right? And so there is not a debate about what is better. There is a debate about what is going to happen. Themistocles famously pushed for the naval build-up. Persia, he wins the debate, they build the navy, Persia will invade the next year, and Themistocles is considered the hero. Because of the Battle of Salamis they destroyed the Persian navy. Is this a story of wise usage of data? No, absolutely not. This is they actually I believe they asked an oracle if Persia is going to invade or not. This is their decision was not informed by science, but what it's really the story highlights is that very often a country will have to build a world model, will have to decide if something is going to happen or not, and the choice will determine if the country will keep existing or will disappear. And this choice will be drastically driven by how much I can predict the future, right? Because this is what will decide if my choices were right or wrong. Now, this is the how to use. So they were asking an oracle, right? How can we do better? Well, since it's not since a lot of time that we use data to inform policy. Probably the first scientist using data for policy is Jon Snow, that is now weirdly famous for knowing nothing, but it's considered the first of the scientists. It's not the same Jon Snow. It's often cited as the first of the scientists, and it's often cited as the first of the scientists because of his approach during the cholera epidemic. Now, the main theory at the time was that the disease transmits through vapors. So one person to another. A person that is sick with vapors transmit to people around him. This was debated, and Jon Snow didn't believe this theory because he thought it was related to a source that was specific in one point. So what he did was to monitor where these the cases happened, right? And he monitored there are many cases here, many cases here, less cases here, very less cases here, and there is clearly a center. Now this kept going on day by day by day, and this is strongly at odds with an idea of a phenomenon where people transmit one from the next. Because if we transmit one to the next, you would observe that the next day you will have a distribution that is wider, because the people now that are here will transmit around them, right? And day by day it will spread. This is not what was going to happen. The cholera epidemic in London kept being centered around a specific point. And this is what Jon Snow mentioned was that the data did not allow to believe the theory. And so we have to drop the theory, right? Because that's what we have to do. If there is data and theory that says different thing, data has to have the priority, even if the theory looks very reasonable. However, it's not enough to look at data. You need also to understand the data. Now, this is it's a famous example. I believe many of you will recognize this what is going to happen here just by the picture. But it's a useful example. This is a map of a plane during Second World War. Planes have a general problem, right? They are a machine that have to fly, but they also have to be resistant. And to fly, you have to be light. And to be resistant, especially if it's a warplane and people are going to shoot at you, you have to be heavy because you need the shields, you need the metal, you need the hard metals. And you have to find a compromise, right? Because you want to be as resistant as possible, but still able to fly and fly fast. So there is a point. So what the army thought was, okay, maybe we can reinforce only some parts of the plane. So let's do this. We wait for the plane to come back and we record where it has been hit. And we reinforce only the parts that are hit more often, right? And so this was the map. So you see most of the planes that were coming back to the base after the mission were hit mostly where there are red dots, here in the center, here on the tip of the wings. And so they said, okay, well, we can just reinforce these parts, doesn't require to reinforce the rest. Now, the problem is that this is a bad use of data, and it's one of the first cases where academia actually intervened in a war. Second World War would be a war where academia would intervene several times, as we know. Intervened with an English mathematician that looked at the data and was a bit surprised by the finding, right? Because he thought, well, my expectation is that a plane will be shot by far away, right? It's not going to aim one place or another. How does it happen that is it hit here but not here, right? Or here but not here? And what he thought was, well, but these are not all the hits to planes. The planes that don't come back to the base because they are dropped are not recorded where they're being hit, right? These are only recorded from the planes that safely come back to the base. What is this map recording is the place where if you hit the plane can still go back to the base safely. It doesn't come back if it's hidden on an engine. It doesn't come back if it's hidden where the pilot stays. It doesn't come back if it's hidden in the center of the wing, because if you hit the plane in the center of the wing breaks, and then the plane falls down. So what he mentioned was we have to do exactly the opposite of what the data would seem to convey at a first glance, because there is a survivorship bias. The planes that are coming back are not random planes. Okay, so this was really after Second World War. This concept was of using data well became central in the way in which we understood the policy. We had the very famous sentence that I think everyone has at least heard: correlation is not causation, right? Very common claim. It's not enough to say that something happens at the same time. We need to establish causation. We need to say that this happens because of this, right? And how it happens. We need to understand the mechanism. And this correlation is not causation, it really became a mantra, especially in economics, where basically, if you say policy relevant and causal, they're basically the same, they're used in the same way. In particular, after Limmer 1983, the very famous paper that was criticizing a lot of usage of data in economics, and it became really centered on the idea we need to understand what is causal, what is causing what. And this is a very reasonable point, but at the same time, there was another discipline that is data science, not related to economics, where instead they were not looking at causation. They were looking at forecasting. They were trying to understand not what causes what, but if I can use the data to forecast other data. And honestly, these 2015 papers from Kleinberg et al., it's really the first, it's not the first, but it's the first widespread, important statement in economics showing that actually also prediction problems are relevant. Prediction problem is a problem where you are not trying to infer why something happens, you are trying to infer what is going to happen in the future. Or you are trying to infer what is going to happen, what is happening somewhere that you don't know, right? By looking at what you know, you try to infer what you don't know. It's a different statement, it's a different conceptual thinking. The idea of Kleinberg et al. Is very simple and I think is very valid. Imagining that you are, it's starting from the assumption that any economist believe that you need to always understand causation, what causes what. And now he's making a counterexample. He's saying, imagine that you are trying to understand the weather. Now, the weather, it's a complex problem. You will understand it. To understand why things happen is very relevant. And he makes but what if we are really interested in causation or not? It depends on our research question. Now, the point of Kleinberg, what he makes is that every policy statement can be divided in rain-dense problems and umbrella problems. A rain-dense problem is something where you want to understand why things happen. Imagine you are to organize a rain dance. You want to, so the weather is dry, there is no rain since a lot of days. You have to organize a rain dance. And you are calling and you are checking, well, organizing a rain dance is costly. Should you organize it? You are looking at the option and you're looking if it's worth it or not. You have to understand why things happen. You have to understand the impact of a rain dance on the weather. It's not enough to understand if after a rain dance it's raining. A forecast is not enough. Why? Well, because it's possible, for example, that after a rain dance it's more likely that there is a rain, just because people do a rain dance when it's not raining since a lot of time, right? And this is could be, and so probably a rain dance, very likely after a rain dance there is rain, but it's not a causal. It's only because it's a bias, like what we saw before for the plane, right? On the other side, an umbrella problem is a problem where you have to decide, should I buy an umbrella? Now, if I have to decide if I have to decide if I should buy an umbrella, doesn't really matter why it's going to rain tomorrow, right? What matters is only, is it going to rain tomorrow? If it's going to rain tomorrow, I want an umbrella. If it's not going to rain tomorrow, I don't want an umbrella. I believe that buying an umbrella is not going to change the probability that tomorrow is going to rain, unless you're very superstitious. And so, it's not a causal problem. It's not a problem where you are looking at the impact of buying an umbrella on the weather tomorrow. You're trying to understand if tomorrow is going to rain. And maybe it's not, and for sure, it's not causal. Okay? But it's still policy relevant. Because if I buy an umbrella and tomorrow is not going to rain, I wasted money. If Themistocles bought the navy, but the Persian wouldn't invade, they would have wasted a lot of money, right? So this is the distinction. Now we will focus mostly on prediction problems. So we'll try to use these data science techniques to predict the future. However, we are not going to look only at what is technically a forecast. So we're not looking at prediction only in terms of predicting what is happening tomorrow. We're mostly looking at three kinds of predictions. So a prediction problem is any problem where we are trying to infer something out of sample. So we're trying to use the data that we know to forecast something that we don't know, right? And we'll see some forecasting, so what is going to happen in the future. So we don't know something because it didn't happen yet. But we'll also look at some nowcasting. Nowcasting is predicting something happening today, not because it didn't happen, it already happened. It's happening at the same time. But we don't know it. We don't have the data about it, right? So, for example, in many African countries, we can use satellite data to understand inequality at the regional level, right? Or at the block level, at the city level, right? It's not because it's in the future, it's something that's happening today, but to collect the data on inequality at the sub-city level in different areas of the city is very costly. And instead I can use satellite data. I take some cities where I know the inequality and I use forecasting technique, prediction analysis to nowcast the inequality in areas that I don't know, that I don't have the data. Okay? And finally, we'll use prediction analysis also for extracting data from unstructured information. So for example, as we saw, satellite data, but also, for example, a text. So we take a text that happens online, and we'll use the prediction analysis to understand if this text implies something. So, for example, we try to understand if by looking at regions that are happy, which kind of post on social media they write, and then regions that are less happy, which kind of post on social media they write, and then for regions that we don't know if they're happy or not, we look at the social media and we try to take this unstructured information, these posts in social media, and we transform them in nowcasting.